So this lesson's on 8.b, which is a three-part series, and it's part one, which is I can graph lines using a linear function using a table of values, right? Now, we're actually going to talk about what a linear function is and all that and break it down before we go into it. So what you have to understand is a linear function is an equation in two variables, right? And that's the key part. The two variables we are working with are generally x and y, right? So it's an equation in two variables whose solutions are ordered pairs that line up in a straight line. And the key part is to understand that the solutions, right, are going to be the ordered pairs that make the equation true. And when you find all those ordered pairs and you plot them, that's what gives you the straight line. There are three forms of an equation of a line that you guys have to know. The first one is slope-intercept form, which is y equals mx plus b. This is by far the most important one to have mastered. The second equation is point slope, which is y minus y1 equals m times x minus x1. And what you have to understand is y1, m, and x1 will be replaced with numbers. The third equation you have to know is standard form, and that is ax plus by equals c form. Okay, now, a couple of things before we go on. Number one is to really understand if an ordered pair is a solution to an equation, it is also a point on the line. Second is to know and understand that a line is made up of an infinite number of points. Meaning, if we plot every single solution to a linear function, there are so many solutions, and when you put them all together, they give you that straight line. So a line is made up of an infinite number of points. However, to graph, you only need 2 points. If I plot 1 point here, I can draw many lines through it, or an infinite number of lines. But as soon as I put a second point on there, there's only one line that can go through any 2 points. Okay? So, looking at this, determine if the ordered pairs are points on the line. Well, with this, determine if negative 418 is a point on the line y equals negative 2x plus 10. Well, in this ordered pair, I know x is negative 4 and I know y is 18. I'm going to take these values and substitute them in. I'm going to replace y with 18 equals negative 2 times x is negative 4 plus 10. That gives me 8 plus 10 is 18 equal to 18? Yes. Therefore, this is on the line. Let's take a look at the second one. Determine if 6 negative 2 is a point on the line x minus 3y equals 12. So in this case, in that ordered pair, x is 6, y is negative 2. So right away, when I go to substitute, replace x with 6 minus 3 times negative 2 equals 12. That gives me 6. Negative 3 times negative 2 is 6, so 6 plus 6. Does that equal 12? And the answer is yes. 12 equals 12. Checks out. So that is on the line. Now the next one, x is negative 3, y is 19. So 19 equals 6 times negative 3 plus 1 is negative 18 plus 1. Going to be a true statement, right? This is not true. Therefore, this is not on the line. All right. So how do we graph these linear functions using a table of values? Well, the first thing we want to do is make sure we're solved for y. We want to have this in that y equals mx plus b form. Now, then we're going to pick 3 easy x values to plug in. If m is an integer, meaning a positive or negative counting number, right? I know I'm going to use 0, 1, and 2 as my input values. There's nothing wrong with using -1, 0, and 1. You can use 100, 101, 102. You can use any values you want. So if m is a fraction, so right, we're going to say m is a over b. Generally, what we use for x is we would say we would use 0, the denominator, and the opposite of the denominator. So in this case, if our fraction was a over b, we would use 0, b, and negative b. And the reason is if I have the fraction 2/3, if I multiply that by the denominator, right? Notice one of two things. One, that gives me 6/3, which is 2, or you notice those eliminate. What does it leave me with? 2. Okay? Now, once we create our table of values, right, then we're going to gather the ordered pairs, plot the points, and sketch our graph. So let's do a few examples here. Number 1, I look. Am I solved for y? Yes. So I'm going to start creating my table. I have x. F of x equals 4x plus 2. And then I have my ordered pair at the end. So the first point, if I look, m is 4. 4 is an integer. So the first value I'm going to plug in is 0. So f of 0 is 4 times 0 plus 2. That's going to give you 0 plus 2, which is 2. My ordered pair, x is 0, y is 2. Next, since m is an integer, my next value is going to be 1. So evaluate f of 1. So 4 times 1 plus 2 gives you 4 plus 2, which is 6. Ordered pair, 1, 6. So if I wanted to, I could get away with graphing this line using 0, 2 and 1, 6. However, I use a third point to check my work. So I'm going to let x equal 2. F of 2 equals 4 times 2 plus 2. 8 plus 2 will give me 10. Ordered pair, 2, 10. And does that point land on the line? Yes. Therefore, I know I did all my work correctly. Example 5 now. If I look, this is not solved for y. So the first thing I'm going to do is solve for y. I'm going to distribute the -3. Y minus 4 equals -3x minus 6. Now I'm going to get y by itself by adding 4, making sure I align like terms here. Those eliminate. Y equals -3x minus 2. Now I can go ahead and create my table. Since m is an integer, right? M is -3. I'm going to use 0, 1, and 2. So y equals -3x minus 2. So y equals -3 times 0 minus 2. 0 minus 2 would give me -2. Ordered pair, 0, -2. Plot my point. Next one, y equals -3 times 1 minus 2. -3 minus 2 will give me -5. Ordered pair, 1, -5. Finally, y equals -3 times 2 minus 2. It's going to give you -6 minus 2, which is -8. Ordered pair, 2, -8. Right away, I can graph my line. And finally, the last one here. First thing I'm going to do, solve for y. I have to get rid of the x term, so I'm going to subtract it. That gives me, don't forget to bring down the negative with that, negative 3y equals, I'm going to write my x term first, so negative 4x plus 15. Now, I'm going to divide everything by negative 3, and y equals, a negative divided by a negative makes that a positive 4/3 x, and positive divided by a negative would be minus 5. Now, I can go ahead and create my table of values. Since my slope, well, m is 4/3, I'm going to start with 0. So y equals 4/3 times 0 minus 5. It's going to give me 0 minus 5, which is negative 5. So 0, negative 5. My next point then, since my denominator is 3, I'm going to use 3. Y equals 4/3 times 3 minus 5. 3's cancel out, leaves me with 4 minus 5, which is negative 1. My ordered pair here would be 3, negative 1. And then I check my final answer by using negative 3. So y equals 4/3 times negative 3 minus 5. A positive times a negative is a negative. 3's eliminate. 4 minus 5 will give me negative 9. So negative 3, negative 9. And now I can graph my line. Go ahead, try the practice, and let me know if you have questions.